We knew that in overflying Russia for 4 years that they were making important advances in radar and missiles. And so in 1958, 2 years before Gary Powers was shot down, we decided we'd try to make a follow-on airplane, which became finally the SR-71, to fly higher and 4 times as fast. So that's the connection between the grandfather type and the SR-71.
Everyone called him Kelly, and as he reminisced that day about the genesis of his Mach 3 masterpiece, he could have just as easily reflected back on a time when aircraft designers were striving for 200 miles per hour, a time when he landed his first job with the fledgling Lockheed Aircraft Company. In 1932, a small group led by Robert E. Gross had purchased Lockheed out of bankruptcy for $40,000 and staked the company's future on the development of an all-metal, twin-engine transport. Models of the design were sent to the University of Michigan, where a young graduate student named Clarence L. Johnson conducted wind tunnel tests. Although his faculty advisors gave the design a passing grade, he wasn't much impressed, and after he'd been hired on as a tool designer at Lockheed in August of 1933, he let Chief Design Engineer Hal Hibbard know about it. Among other things, it'd be directionally unstable, especially with one engine out. A rather presumptuous and certainly unconventional way for a 23-year-old to start his career with a new company, but it was only a hint of what would follow. The son of Swedish immigrants, he'd been nicknamed Kelly by classmates because of his quick temper, stubborn tenacity, and unwillingness to back down from a fight, even against overwhelming odds. Instead of reminding the outspoken young man of his place, Hibbard suggested he go back to the wind tunnel and see if he could improve the design. After 72 test runs, he came up with the solution, an unconventional twin-tail arrangement soon to become a Lockheed trademark. And the Model 10 Electra became the foundation for Lockheed's future growth as various models of the airplane helped revolutionize commercial air transport in the 1930s. With his work on the design, Kelly Johnson became the 6th member of an engineering department in an industry which then couldn't afford specialists. Working often simultaneously as an aerodynamicist, stress analyst, weight, wind tunnel, and flight test engineer, he also put in long hours out in the shop, getting hands-on production experience and learning firsthand the importance of designing producibility into an airplane. It was a real-world education on all phases of design and development that within a decade couldn't be duplicated, and the lessons learned became guideposts for the rest of his career. He flew, for example, as flight test engineer on all models of the Electra, and worked for some of the most notable figures in aviation, such as Amelia Earhart. Out of this experience came his lifelong conviction that the designer had to be able to test his own airplane. As he later commented,
and I decided at an early age that unless I had hell scared out of me once a year, I wouldn't have the proper balance to really design new airplanes of any type.
Kelly Johnson would log more than 2,300 hours as a flight test engineer. The versatile Electra spawned 2 major developments. One was the XC-35, a modified Model 10, which in 1937 first demonstrated the practical feasibility of transforming the entire fuselage into a pressurized cabin to permit comfortable high-altitude flight. Johnson was Lockheed's flight test engineer on this project, gaining first-hand experience with the problems of pressurization, and more important, with the tremendous possibilities pioneered by this aircraft. Possibilities to which he and Hal Hibbard began to give serious consideration. Meanwhile, the Model 14 Electra incorporated a number of Johnson innovations, such as the first practical application of Fowler flaps, which both increased the wing's lifting surface and served to permit slower, shorter distance landings, an achievement which won him the 1937 Lawrence Sperry Award. In 1938, the high-speed and innovative features of the Model 14 attracted British interest in its potential as an anti-submarine patrol plane. But the requirements necessitated a major redesign. Johnson worked around the clock for 3 days transformed the Model 14 into the Hudson bomber. The British ordered an initial batch of 250 aircraft, at that time the largest production order ever received by an American company. But there would be many more, 2,000 to the RAF alone, out of a total production run of nearly 3,000 airplanes. The Hudson put Lockheed into the big time. But even as production was gearing up, Kelly Johnson and his colleagues were well into other much more ambitious designs. The success of the pressurized XC-35 and the recognition that the next generation of air transports would be much larger, higher-speed, transoceanic aircraft inspired Johnson, Hibbard, and a small design team to lay out the now classic lines of the Model 49 Constellation in 1939. Using his soon-to-be legendary powers of persuasion, he convinced Lockheed to build its own wind tunnel, a decision that paid for itself many times over during the development of this design, as all aerodynamic problems were overcome early on, and not one external change had to be made to the actual aircraft. Hibbard was so impressed by Johnson's wizardry that he swore he could see air. Commercial development of the legendary Connie would be delayed by the war, and it first flew as the Army Air Force's C-69. This, however, provided time to refine the airplane so that at war's end, Lockheed was postured to capture a lion's share of the commercial market, and various models of the elegant Connie would continue to grace the world's airways into the late 1950s. At the time he laid down the basic design of the Constellation, Johnson was already well into another path-breaking project. In early 1937, responding to an Air Corps requirement for a high-altitude interceptor capable of 360 miles per hour, Johnson and Hibbard hastily conceived some possible configurations, depicted here in one of Kelly's rough sketches. As Johnson observed many times, in design, you're forced to develop unusual solutions to unusual problems. Their decision to go with an unconventional twin-boom configuration was dictated by another axiom. Design features are the creatures of necessity. The twin booms evolved as a logical development of engine nacelles which had to be extended to house the liquid-cooled engines, turbo superchargers, radiators, and main landing gear. It seemed logical then to simply extend the nacelles into booms which could carry the empennage. Their novel approach produced a winning design, and when the XP-38 was finally rolled out in January of 1939, its sleek lines bespoke speed. And when Lieutenant Ben Kelsey took it up for its maiden flight, it delivered an impressive 403 miles per hour, far exceeding the requirements. Thus began the saga of the P-38 Lightning. The first American aircraft able to fly at such speeds, it offered dazzling performance and a host of new problems. For as it peeled over into dives at high altitudes, it could hit speeds approaching 500 miles per hour. In this region, the aircraft began to violently shake and nose over into increasingly steeper angles, and control forces became so heavy pilots couldn't pull out. Tragically, some never recovered. Kelly Johnson wasn't taken by surprise. Although many insisted it was tail flutter, he immediately recognized it as the then little understood phenomenon of compressibility. At 500 miles per hour, localized airflow over certain parts of the aircraft was reaching supersonic velocity, and this produced shock waves and serious problems. The P-38 was the first aircraft to encounter this, and so little was actually known about it that Johnson launched exhaustive wind tunnel studies and an accelerated dive test program headed by Chief Test Pilot Milo Burcham. After more than 2 years, he finally identified the problem as shock stall on the wing, which reduced lift and increased drag, thereby inducing the nose-down tuck. Typically, he was quick to devise a cleverly simple remedy, a dive flap mounted to the main wing spar that, when deployed, generated a positive pressure field, immediately restoring lift and a nose-up pitching moment. Flown on every battlefront, the P-38 excelled in combat. Christened the fork-tailed devil by Germans, The versatile fighter, combining speed and load-carrying capability, proved adaptable to a wide array of combat roles, and its long legs made it ideal for the vast reaches of the Pacific, where it destroyed more enemy aircraft than any other Allied fighter. Impressive though it was, Kelly Johnson was never satisfied with it. He'd long foreseen the inherent limitations of prop-driven aircraft, and though unaware of developments in Germany and England, where turbojets had already been successfully developed, he decided that props had to go. Thus he and Hibbard became the first in this country to seriously pursue the possibilities of turbojet propulsion, when in 1939 they asked Nathan Price to design an experimental turbojet power plant. Design of the L-1000 got underway in 1940, and by 1942, Price had come up with a truly advanced design, a high compression ratio, twin spool, axial flow power plant promising an extraordinary 5,100 pounds of thrust. Meanwhile, Johnson and a young engineer named Willis Hawkins led a design team that came up with the L-133, a truly radical twin-engine stainless steel aircraft featuring thin wings and canard surfaces and projected to achieve 625 miles per hour at 50,000 feet. But surprisingly, when Johnson submitted a proposal for development of the engine and airframe in March 1942, the Army Air Forces showed little interest. Although launched long after his effort, top-secret development of an American turbojet fighter powered by a British Whittle engine was by then already underway. The Bell XP-59A first flew at Muroc Army Air Force Base on California's high desert in October of 1942, but it proved to be underpowered, overweight, and scarcely optimized for jet flight, and early on, the Army Air Forces decided that it wouldn't meet frontline fighter requirements, though Bell didn't yet know this, and the testing continued. On June 10, 1943, a Bell engineer at Muroc reported back that Johnson had been permitted to examine the still top-secret XP-59A, and he wondered what he was up to. Unbeknownst to Bell, the Army Air Force had already asked Lockheed to submit a proposal for a simpler, single-engine jet fighter built around a 3,000-pound thrust Alfred H-1 engine, which would be capable of frontline service. Johnson took in a lot that day, but he'd already been wrestling with jet propulsion for nearly 3 years, and he already had a suitable design well in hand. When he made his proposal at Wright Field on June 18th, he made the astounding promise that he'd deliver an aircraft within just 180 days. Getting immediate approval, he was cautioned that the utmost secrecy was required. Lockheed was already swamped in terms of manpower, tooling, and facilities with wartime contracts. But this was a blessing in disguise, an opportunity to implement an idea he'd been pestering Robert Gross about for years. Let him round up a small group of talented people, designers, engineers, and shopmen, put them under one roof where they could all work closely together, and give him complete authority over everything from procurement to flight test. With no other options, Gross said, "Go ahead." Stealing people from around the plant, just 28 engineers, including himself, and 105 shopmen, he also built a small facility out of discarded shipping crates, using a circus tent for a roof. On June 19th, he laid down the principles under which the project would operate. In 1.5 pages, now preserved on old photostats, they formed the basis for how he'd try to operate for the next 30 years. He'd be responsible for all decisions. Paperwork and red tape would be cut to the minimum. Each engineer would be designer, shop contact, parts chaser, and mechanic, and each would remain within a stone's throw of the shop at all times. There'd be but one object: to get a good airplane built on time. The daily log indicates that 2 days later, he laid out the horizontal structure of the organization. No pyramidal, multi-tiered layers of management. Each project engineer and the shop foreman would report directly to him. And in fact, he'd be looking over everyone's shoulder, He wanted information direct from the men doing the work, and if they had questions, they'd get decisions immediately on the spot. He'd promised the airplane in 180 days. As would become his custom, he gave his men 150. The clock started ticking on June 23rd. Forcefully reminded that simplicity is the keynote of good design, the designers jumped into their work. But this was a new kind of operation, and instead of moving from stage to stage, the schedule demanded an extraordinary degree of concurrency. With finished detailed design still many weeks away, the mock-up was started on June 30th and completed by July 17th. By then, milling and fabrication of parts and the construction of jigs to assemble a prototype was already well underway, and by July 31st, the bulkheads were going into the jigs. And section by section, the airframe started coming together. Throughout this period, however, the design process continued. As concurrent wind tunnel tests revealed problems, the wing and the engine air inlets were the biggest headaches. He'd gambled on the wing, a laminar flow airfoil that had never before been tested on an airplane. And of course, nobody had had any experience with inlets. Johnson was willing to accept mistakes on such an accelerated and risky venture, as long as they were reported promptly. Typically, he never asked why, but what are you going to do to fix it? The project was so secret that his group didn't even have a name. The whole setup reminded one of his design engineers, Irv Culver, of the mysterious place where Hairless Joe, one of Al Cap's cartoon characters in Little Abner, ground up skunks, old shoes, and other unsavory ingredients to brew a potent concoction called Kickapoo Joy Juice. So inspired, he answered the phone one day, Skunk Works, inside man Culver. Though Johnson wasn't amused, his organization suddenly had a name that stuck. Remarkably, the completed aircraft arrived at Muroc on November 14th, just 143 days after startup. But when the engine was run up 3 days later, there was a terrific roar as the inlet ducts collapsed, sending debris into the engine and cracking the impeller. It took 6 weeks to get a new engine, but on January 3rd, 1944, Milo Burcham successfully completed the taxi tests. And 5 days later, in the chill of the morning on January 8th, Johnson, in white coveralls, overcoat, and stocking cap, worked intently with his crew preparing for the first flight, as over 100 Skunk Works employees stood atop a hill looking on. He wanted everyone who'd worked on the airplane they now call Lulu Bell to be on hand. He told Burcham, just fly her, Milo, and find out if she's a lady or a witch. At 9:15, he took off. But only 5 minutes later, was taxiing back to report that the landing gear hadn't retracted and that the boosted ailerons felt too sensitive. While the gear problem was being fixed, Johnson assured him that the control sensitivity was normal, and at 10 o'clock, he took off again, and this time put on a dazzling 20-minute display, attaining a top speed of 490 miles per hour and reporting a roll rate of 360 degrees per second. Back on the ground, he was able to report that Lulu Bell was indeed a lady. The XP-80 ultimately became the first American aircraft to exceed 500 miles per hour, but this was only the beginning. For months, Johnson had been working on a larger, more advanced version with a 4,000-pound thrust General Electric I-40 engine, promising much greater speed. He promised the XP-80A in just 150 days and delivered it in 132. But as Tony Levere taxied in after the first flight on June 10th, he'd had a few surprises. Center of gravity miscalculations had caused porpoising. A faulty pressurization valve had channeled 325-degree engine bleed air into the cockpit, and malfunctioning flaps put the airplane into violent rolls. Only his superb flying skills allowed him to bring it back, and Johnson was so grateful he doubled Lever's bonus, a gesture pointing up the special relationship between them, and indeed between Kelly Johnson and all of his test pilots. Unlike so many of his peers, Johnson both understood and appreciated what his pilots did. He flew with them whenever possible, shared their concerns, always listened, and then acted on their recommendations. The XP-80A's problems were quickly remedied, and it went on to become the prototype for America's first operational jet fighter. Though it wouldn't enter combat in World War II, the P-80 Shooting Star would deliver awesome performance. In January of 1946, for example, Colonel William Council completed the first non-stop transcontinental jet flight covering 2,450 miles in a record 4 hours and 13 minutes at an average speed of 580 miles per hour. In June of 1947, flying a specially modified P-80R, Colonel Albert Boyd completed 4 runs over a speed course at Muroc, averaging 623 miles per hour, and reclaiming the world speed record for the United States for the first time in 24 years. And over Korea in November of 1950, a Shooting Star put down a MiG-15 in history's first all-jet combat. And amply confirming Johnson's methods and his insistence on simplicity, the P-80 would give birth to a number of progeny. Shrewdly sensing the need for a jet trainer, Johnson gambled $1 million of Lockheed money on the development of an F-80C airframe into a 2-seat configuration, which after its first flight in March of 1948 was transformed into the classic T-33, an airplane affectionately called the T-Bird, which would serve as the standard jet trainer for legions of student pilots around the world for the next 3 decades. In response to an urgent Air Force requirement for an interim all-weather interceptor, the T-33, in turn, served as the basis for 3 different models of the F-104 Starfighter, which filled a critical void while newer designs specifically tailored for that role remained under development in the early 1950s. Not done yet, the now vintage design would realize its final incarnation as the T-2V1 Sea Star, an advanced, navalized version of the T-33. All of the iterations of the P-80 design were still yet to come, however, as in 1946 he started design work to meet an Air Force requirement for a new penetration escort fighter. Early on, he explored the possibility of applying new concepts, a delta wing, even in-flight variable wing sweep, and then discarded both, some of the more than 60 concepts he'd examine and reject. When the XF-90 finally rolled out 3 years later, it was the victim of ever-changing and conflicting requirements, from a time to climb of 35,000 feet in 10 minutes to 50,000 in 5, 900-mile range to 1,500, and then back to 600, and finally ground attack capability and a high-speed, high-altitude design. This prompted him to build a brawny airframe, over 30,000 pounds fully loaded, and stressed for over 13 Gs. When Tony LeVere took off on its first official flight, he had to use rocket assist because the pair of small 3,000-pound thrust J-34s still lacked afterburning capability. The usual post-flight congratulations and festivities belied the fact that Johnson knew he was facing terrible odds. With the same pair of inadequate engines as their principal rival, the McDonnell XF-88 at half again as heavy because the 88 hadn't been beefed up for ground attack, Johnson's airplane was bound to suffer performance-wise. It was overweight and underpowered, and even when afterburning was finally added, boosting combined thrust up to more than 8,000 pounds, its top speed in level flight was only 668 miles per hour, slower than existing operational F-86s. It achieved one distinction, however, when in April 1950, LeVere pushed over into a steep dive, and it became the first Lockheed airplane to exceed the speed of sound. With performance no better than the XF-90s, The McDonnell entry won the competition, but neither design went into production. The whole ordeal taught Johnson never again to take on a job unless the requirements were both well-defined and firm. Even though a failure, the XF-90 went on to demonstrate that he certainly knew how to build a rugged airframe, as in April of 1952, it survived the first of a series of atomic blasts, suffering only 20 hours worth of repair work. Meanwhile, Johnson was completing work on a much more unconventional airplane. Designed to meet a Navy requirement for a vertical takeoff and landing, or VTOL fighter, the XF-V1 was supposed to claw its way straight up by means of huge contra-rotating props driven by a twin turbine power plant, providing more power than the airplane's weight. Engine development lagged, however, and after test pilot Herman Fish Salmon first lifted off from the lake bed at what was now called Edwards Air Force Base in December 1953, the underpowered XF-V1 continued to rely on its makeshift landing gear for all takeoffs and landings. Once aloft, however, Salmon was able to demonstrate that it could make satisfactory transitions from horizontal to vertical flight, and that it could hover in the vertical attitude. But lacking the promised power, and explaining in his words that it's awful hard to fly an airplane looking over your shoulder, Salmon wasn't eager to attempt vertical liftoffs or touchdowns. Neither was Johnson, who, believing a designer shouldn't be afraid to fly his own airplane, had the integrity to recommend cancellation of the whole project. By that time, however, he already had a much more promising design on the ramp at Edwards. When Tony LeVere first saw it, he asked incredulously where the wings were. But those tiny, blade-thin wings and everything else about the XF-104 were actually the product of years of careful thought, effort, and Johnson's determination this time to employ his Skunk Works methods. Back in 1947, he'd modified a P-80 with wingtip-mounted ramjets, and with Fish Salmon at the controls, it became the first piloted aircraft to fly on ramjet power alone. These tests supported a major Skunk Works type of effort to explore a whole new realm. At a time when missile and guidance system technologies were still in their infancy, Johnson's team had to design a pilotless Mach 3 testbed to further explore ramjet technology. The X-7 was the product of their efforts, and its tiny, thin, slightly tapered wings, Johnson's solution to the problems of high Mach flight, had been thoroughly tested on rockets and with scale models. The X-7 first flew in April 1951, and it went on to a remarkable career. Launched from a B-29, boosted to high speed by powerful rockets, and then flying on various ramjets under test, it ultimately exceeded Mach 4 and climbed well above 100,000 feet. Thus those small, thin wings were already more than just a theory when Johnson visited the Korean battlefront in 1951. Still smarting from the XF-90, he'd gone there to talk to the ultimate customers, combat pilots, about what they wanted in a fighter. To a man, it was higher speed, more altitude, and less complexity. Intent on giving them just that, he made an unsolicited proposal to build a fighter for which no requirement yet existed. When he promised Mach 2 and 60,000 feet in a simple, lightweight fighter, Colonel Bruce Holloway stepped into the next room and within 2 hours returned with a short 1.5-page list of requirements. This time, with a firm, straightforward requirement, Johnson returned to his favorite Skunk Works mode of operation, and less than a year later, in February of 1954, Tony LeVere lifted the XF-104 from the lake bed for its first flight. Though configured with a much lower thrust engine than the powerful J-79 scheduled for the production model, the XF-104 was still faster than any other fighter in the world. But Johnson had produced more than just a dazzling performer. Fanatical about costs and producibility, while design of the prototypes was still underway, He'd set up a small group of engineers to find the cheapest and most efficient way to produce each part of the production airplane, an innovation which would result in savings of about $12,000 per aircraft and millions for his customers. When the press finally got to see the F-104, they called it the missile with a man in it, and they weren't far off the mark. The first Mach 2 operational aircraft in the world, it would go on to shatter every significant record on the books. 91,000 feet and 1,400 miles per hour in May of 1958, making it the first aircraft ever to hold both the world altitude and speed marks simultaneously. 3 time-to-climb records later that year. And in 1959, it became the first airplane taking off on its own power ever to climb above 100,000 feet, as Captain Joe Jordan zoomed up over 103,000 feet. This kind of performance clinched the 1958 Collier Trophy for Johnson. While the Starfighter was capturing headlines with record-breaking performances, another, much more exotic Johnson design was unbeknownst to all but a few, almost daily cruising in level flight at altitudes far beyond any official records. It had been born of the massive arms buildup of the early 50s, when U.S. intelligence agencies urgently needed confirmation of reports of major Soviet advances in intercontinental range bombers and ballistic missiles. The decision to proceed with overflights led to a design competition for a reconnaissance aircraft capable of 70,000 feet. Though Lockheed hadn't been invited to participate, Johnson had caught wind of it and hastily submitted a proposal to build the CL-282, essentially a modified F-104 with a wide-span, high-aspect ratio wing. Though it lost out to the Bell X-16, Kelly Johnson wasn't about to quit. Over the years, he'd gotten to know a lot of people in high places, and he developed consummate lobbying skills. With a revised design and promising an airplane within just 8 months, he got the go-ahead to produce 20 aircraft for $22 million. The project, codenamed Aquatone, was directed by the CIA's Richard Bissell, who found the Skunk Works' streamlined, informal method of getting things done much to his liking. Secrecy limited access to a mere handful of CIA and Air Force personnel, which was fine with Johnson because it freed him from a lot of needless paperwork and interference. The urgency of the project also freed him from what he regarded as the tyranny of technical specifications. His customers simply wanted an airplane that could do the job, and all he had to do was deliver on time. While the article, as it was called, was a relatively conventional design, the extreme altitudes at which it was supposed to operate imposed severe demands. Forced to ruthlessly cut weight, he reduced structural components to the minimum and designed delicate, glider-like wings spanning 80 feet and weighing less than 4 pounds per square foot. The fragile airframe was designed around a special high-altitude version of the J-57 engine, virtually hand-built to extremely high tolerances and originally producing 10,500 pounds of thrust. When the disassembled aircraft was unloaded from a C-124 at a remote desert test site in July of 1955, Johnson had met yet another seemingly impossible deadline. After reassembly, it was rolled out into daylight for the first time and painstakingly prepared for its taxi tests. On August 1st, as he had so many times in the past, Tony LeVere climbed into the cockpit. During his third run that day, he suddenly noticed that he was more than 30 feet off the ground. Coming down hard, the tires blew and the brakes failed and caught fire. Reporting afterwards, he explained that at 70 knots, I became aware of being airborne, which left me with utter amazement, as I had no intentions whatsoever of flying. Those fragile wings had more than enough lift. He completed the first real flight 4 days later, and on a subsequent flight reported that the aircraft climbed toward the heavens like a homesick angel. To conceal its true purpose, the angel was given the misleading official designation U-2, and a cover story was released to the effect that it was being developed as a high-altitude research vehicle for the National Advisory Committee for Aeronautics. While it would perform this role admirably, tests focused on preparing the U-2 for its real mission, to carry 700 pounds of high-resolution camera equipment up to altitudes then beyond any air defense capabilities. And in July 1956, just 11 months after first flight, it commenced its clandestine operational career. Climbing to well above 70,000 feet as fuel burned off, the U-2 successfully completed flights over denied areas and brought back the first hard data on the status of Soviet military preparedness and the true extent of its intercontinental ballistic missile program. Called the Dragon Lady by its pilots because it reminded them of the beautiful, mysterious, and sometimes treacherous character in the Terry and the Pirates cartoon strip, it flew with virtual impunity for 4 years until that day in May of 1960, when Francis Gary Powers was shot down by a surface-to-air missile. While deep penetration of Soviet airspace came to a halt, the U-2 continued to overfly hotspots around the world, such as in 1962, when it confirmed the existence of missile launch sites in Cuba. And it would also continue to perform an incredibly wide array of extremely high-altitude research missions. Kelly Johnson had reason to be proud of his angel. The Skunk Works had finally been formally established as Lockheed Advanced Development Projects, and on this, its first production program, he'd refunded $2 million from the original $22 million contract and built an additional 6 airplanes out of spare parts. Surely one of the best bargains in defense procurement history. That pride was rekindled when in 1981, the larger, more sophisticated TR-1 was rolled out years after U-2 production had ended. It was the first time the Air Force had ever put an aircraft back into production, and it remains, to this day, the highest flying single-engine aircraft in the world. Back in December of 1956, the Skunk Works' remarkable performance on the U-2 had convinced Lockheed to give Johnson the job of designing and developing prototypes for a small military jet transport. Dollars were scarce, competition keen, and he'd only have 8 months to do the job. Being on time had always been one of his cardinal rules, and in just 241 days, he delivered the JetStar. He'd actually been working on designs for a large jet transport since 1944. And this trim little craft was actually a scaled-down version of the L-193, the innovative 1953 design which the airlines had feared too risky to support. Johnson, who continued to put in long hours as a flight test engineer on this project, was out to prove them wrong. And he was more than pleased with the results. A top speed of over 600 miles per hour, a peak altitude of 52,000 feet, and with wing tanks, a range of over 3,000 miles. The JetStar easily won the competition, and though only a limited number went into military service as C-140s, ultimately more than 200 were produced, and a great many of them remain in service to this day. The JetStar was a pleasant diversion as he worked on another, much tougher project. Even as development of the U-2 was still underway, he'd projected that aero defenses would catch up with it within 2 years, and he'd initiated a remarkable series of design studies for a liquid hydrogen-fueled supersonic successor capable of climbing above 90,000 feet. Performance varied from Mach 2.5 and a range of 2,200 miles to Mach 4 and 9,000 miles. Because of the extremely low volumetric density of liquid hydrogen, however, the latter speed and range capability could only be achieved by building an airframe twice the size of a B-52. That was far too costly, and thus a much smaller design at the lower end of the performance spectrum went into development as the CL-400 in 1956. Though the CL-400 proved the technical feasibility of a liquid hydrogen-powered aircraft, Johnson was dissatisfied with its short range and convinced that the problems of producing and transporting fuel around the world were insurmountable. Refusing to build an airplane he didn't believe in, he recommended cancellation of the project in 1957. But he had an ace up his sleeve. As concurrent with the liquid hydrogen studies, he'd also examined the potential of another advanced design using jet fuel, which at some loss in altitude promised Mach 3 cruise and 4,000-mile range. It was the genesis of his most spectacular creation. Given approval to proceed, in April of 1958, Johnson began a series of design studies, unveiled publicly here for the first time, for what he initially called the U-3, and then the Archangel, because it would soar much higher than the U-2. He explored various means by which he could get the vehicle to altitudes as high as 150,000 feet, employing a variety, or even a combination of rocket, ramjet, and turbojet power plants. At one point, he looked at the use of balloons to lift it to its rocket boost phase, and then at using a modified U-2 to tow a ramjet vehicle to 60,000 feet for engine ignition. He even considered a multi-staged vehicle, and one with inflatable wings and empennage. And throughout, he was challenged by the urgent need to reduce radar cross-section. For the first time, stealth would have to be designed into the airplane. The intense design gestation process was completed in just 16 months, and when he presented his 12th concept to the CIA and Air Force in August 1959, he got the go-ahead. When the stunningly beautiful A-12 was finally rolled out for its initial tests in April 1962, it wasn't some fantastic, multi-staged aberration. It was an honest airplane, but nothing like it had ever been built before. Ironically codenamed Oxcart and designed for sustained Mach 3.2 cruise at altitudes between 75 and 95,000 feet, it posed by far the greatest challenge of Johnson's career, as everything from structural materials to hydraulic fluid and fuels had to be invented from scratch. For example, because of the intense heat at sustained Mach 3 speeds, averaging more than 550 degrees on the surface of the airplane, Johnson employed a titanium alloy for more than 90% of the airframe. But no one had ever before attempted to process such quantities of the extremely hard and brittle metal to the purity and strength levels required, and thus new forging and milling processes had to be invented and perfected. When the thin titanium skin on a wing panel shriveled up during heating tests, Johnson separated the panels from the wing spars with extrusions and put the now famous corrugations in the skin. When heated thereafter, the corrugations merely deepened a few thousandths of an inch and on cooling returned to their original shape, a common-sense solution to a difficult problem. There were literally thousands of such problems to overcome, and as always, Johnson stayed on top of all of them, looking over people's shoulders and asking lots of questions, always the best way, in his view, to get people to solve problems. And he continued to amaze everyone with, for example, on-the-spot predictions of skin temperatures, which after hours of calculation, they'd find were within 1 or 2 degrees of the exact figure. The whole effort, completed in absolute secrecy with an incredibly small group of people, was all the more remarkable because it was done without the benefit of computers. As Johnson later recalled,
when you think back to 1958, when the basic design work on the prototypes for this airplane was being designed and built, we had to make use of the Michigan computer, which is a 12-inch slide rule, and it did its job quite well.
All of this prodigious effort was about to come to fruition when on April 25, 1962, preparations for high-speed taxi and an initial brief liftoff were completed. But as loose shock sped down the runway, He encountered nose-wheel steering problems and had to kick in heavy right rudder. Then, as Johnson wrote in his log, the aircraft got off the ground and there was an immediate change of rudder angle. This set up lateral oscillations which were horrible to see. Schock was lucky to get the airplane back on the ground. The problem was fixed post-haste, and the next day he completed the first unofficial flight with the gear down. On April 30th, Johnson was back with an entourage of VIPs for the official first flight. Looking like he didn't have a care in the world, he offered a few last words of encouragement and advice before Schock taxied out. And from there, everything went flawlessly. "59 minutes later, Schock was back on the ground, welcomed by an elated Kelly Johnson and the small, awestruck assembly who just witnessed something very special. Limited by interim J-75 engines, the A-12 didn't begin to realize its full potential until after the Pratt & Whitney J-58s, for which it was designed, finally arrived in January 1963. At 32,500 pounds of thrust, the turbo-ramjet J-58 was every bit as exotic as the airplane itself. In combination with an extremely complex inlet and exhaust ejector system, it operated as a normal afterburning turbojet up to speeds of about 1,600 miles per hour, and then shifted its cycle, largely bypassing the compressor and becoming essentially a ramjet, with the inlet actually providing most of the thrust at Mach 3 cruise. When a two-seat trainer became available in early 1963, Johnson, true to his convictions about flying his own aircraft, jumped into the rear cockpit. And, taking control after climb-out, he'd fly supersonic for the first time in his life. During the course of the test program, a pair of airframes were modified for a highly unconventional mission. In 1964, the Skunk Works built a small, 42-foot-long airframe with the very same materials used on the A-12. Designed to overfly areas deemed too risky for air crews, the D-21 drone would ride piggyback atop an A-12 for Mach 3 launches at 80,000 feet. And powered by a ramjet originally developed for the X-7 program, it would be even faster than the A-12. The finished article was mounted to its mothership, now designated M-12, in December 1964. And on December 22nd, the unusual pair taxied for the first time, and flight tests got underway. After takeoff on launch missions, the M-12 climbed to a rendezvous with a KC-135 for refueling, and then proceeded on to the predetermined launch point, where the backseater would monitor the systems and initiate the launch procedures. While there were several successful tests, it was always a very risky business at best, and Kelly Johnson personally canceled this program after a fatal mid-air collision in 1966. By then, however, he already had two other very successful ox cart progeny off the ground. The first was the YF-12A, prototype for a proposed high-speed interceptor. It was this aircraft which went on public display when in 1964, President Lyndon Johnson announced the existence of the A-11. And it subsequently put on a dazzling show, as in May 1965, it claimed no less than 9 world records, including a top speed of more than 2,000 miles per hour and a sustained altitude of over 80,000 feet without in any way taxing its full potential. The YF-12 was equipped with an advanced ASG-18 Doppler radar system and configured to carry 3 AIM-47 missiles internally. Though missiles had never before been launched within the YF-12 speed and altitude regime, the aircraft and its systems scored a reported 90% kill rate even against drones flying head-on down on the deck at distances of 120 miles and more. The Air Force was impressed enough to order 93 of the big fighters into production for the Air Defense Command, but budgetary constraints ultimately resulted in their cancellation. And shortly thereafter, the A-12 was also removed from service, leaving only the Air Force's SR-71, which took over its reconnaissance mission. Though everything about it and its activities would remain cloaked in a heavy shroud of secrecy, this was the aircraft that everyone came to know as the Blackbird. The solid coat of black paint, which seemed to add to its allure and mystery, actually had a very practical purpose. It reduced skin temperatures by about 75 degrees. Its clean, elegant lines and the smooth contours of its blended wing-body shape give the impression that an artist had sculpted it into a rare work of art. In aircraft design, however, more than any other field, form follows function. And here again, every line, every detail of the airplane exists only to serve some practical purpose. The chines, for example, which extend from the wing to the nose and flow gracefully up into the fuselage, actually satisfied a number of requirements. Aerodynamically, they reduced drag and added lift while also enhancing the stability of the aircraft. The SR-71's mission was long-range reconnaissance, and its fuselage was essentially a big fuel tank. And thus the chines also served to house its sophisticated cameras and sensors. Finally, those sloping contours extending up from the chines enhanced the airplane's survivability by reducing its radar cross-section. Thus, while an artist might envy its striking beauty, an engineer would only marvel at the logical genius of its design. That genius was recognized when, in 1964, Kelly Johnson became the first person ever to be awarded a second Collier Trophy. The SR-71 would go on to claim every speed and altitude record in the books, and then repeatedly extend its own records. And to the public, it always remained Kelly Johnson's mysterious, record-breaking Blackbird. The crews who flew it, however, had another name for it. Throughout its long operational career, it remained invincible and incredibly effective. And to its crews, it was Habu, a dark-skinned pit viper with a deadly bite. And though it was finally retired from Air Force service in 1990, Kelly Johnson's Mach 3 masterpiece is still charting the future, its crews still looking up toward the blue-black void of space, flying exotic research missions for the National Aeronautics and Space Administration. When he retired in 1975, Kelly Johnson had been on the cutting edge of an advance from 200 to more than 2,000 miles per hour. He'd been involved in the design of 44 different airplanes, many of them among the classics of aviation history. And at the time, he was still looking very much into the future. He'd gotten the Skunk Works into a project which would bear fruit in the F-117A, the world's first true stealth aircraft. And he'd left a legacy which would leave its mark on the future. It seems kind of ironic that a lowly creature, known primarily for its odoriferous emanations, had, by the time he retired, become a universal symbol for excellence. What was his secret? Well, he had a remarkable capacity to take a complex problem, reduce it to its simplest components, and then take the most direct and sensible approach to its solution. Always a maverick, he was smart enough and tough enough not to follow the committee rule of conventional wisdom. This gave him remarkable freedom. With that freedom came a tremendous burden of responsibility. Finally, and most important, he understood himself well enough to realize that with a few good people, you can do remarkable things. Kelly Johnson's most important legacy wasn't what he did, but the way he did it.